So thanks, Lynn, for the introduction. Yep, we're doing the last bits of the hands-on lab that we didn't get to finish last time. So again, just a quick review of what the goals are of this lab. We're building upon last year's hands-on lab, which is very, very popular, to focus on more advanced use cases and kind of best practices or preferred practices for dynamic cubes. And if you missed the link from last time, you still have a chance to take a look at the recordings from last year's labs in two parts that are out on YouTube. There's two links down here at the bottom of the screen. Just a review of the agenda. So this week we're gonna follow up and finish out the last three bullets out here on the agenda for the lab modules. We'll finish out optimizing a cube's performance. Then we'll take a look at enabling reporting on analytics on historic and planned data in one place using Virtual Cube. And then we'll round it out by looking at the near real-time feature by incrementally updating data caches so you can have less cube maintenance. Again, a review of the highlights of what's new. In today's session, we'll be focusing on two of the new things that came out in FixPack 10.2.1 FixPack 3, one being the DC admin command line administration tool. I'll show that when we go over the incremental update module, as well as, well, I just mentioned it, the incremental updates of cube data. And quick review of the cube dynamic cube lifecycle is it starts out, with the warehouse, and you have your star schema. You go into Cube Designer, where you do your modeling of your dynamic cube, publishing that cube information, the model, to Content Store, where it stores the metadata and the model. Then you deploy your cube to a query service, where you would then manage it within Cognos administration. Starting the cube up would start an instance of the cube in the dynamic cube. Once that cube is started, up and running, your users can then go into Cognos Studios, any of the Studios, Workspace Advanced, Report Studio, what have you, to do reporting and analytics against the running instance of the cube. You might want to improve the performance and optimize the cube a little bit. You would then, as you covered in last week's, or not last week's, last time, going through the dynamic query analyzer and running through the aggregate advisor workflow to get recommendations for in-memory and in-database aggregates. Again, a review of the schema used in this lab. It's a basic star schema with a little snowflake off the product dimension, with historic sales as the fact table in the middle, with the 5 dimensions all around, with retailer product time, promotions, and order method. So let's jump back into where we left off with the module about optimizing a cube's performance. So I'm just going to breeze through this. Last week we went through the aggregate advisor workflow, where you would enable workload logging and then run the aggregate advisor to get recommendations of your in-memory aggregates, and a quick one-button click to apply those in-memory aggregates, and once you restart the cube, you get those in-memory aggregates are loaded automatically. The database aggregates, you would send that text file to your DBA, who would then create the database aggregate on the back end, model that into your cube, restart it. Dynamic Cube engine will guarantee routing to those aggregates. Having aggregates and all that is one approach to optimizing performance. Another is to run priming reports. As we saw in last time, we were able to identify certain reports that we wanted to run right after certain events, and we took a look at the new trigger that was added in 10.2.2. It's a new trigger where you can assign reports to run after in-memory aggregates are done loading. There's an existing trigger for after cube startup, and we added a new one at 10.2.2 for after in-memory aggregate load. So we went over that last time. Last time we also talked about user-defined in-memory aggregates. You may find, after you've gone through the whole aggregate advisor workflow and priming and the caches and all that, that you still might want to define other in-memory aggregates that you want in your system, or you might know your system a little bit better and you wanted to accelerate getting in-memory aggregates. So we also went over how to define in-memory aggregates in Cube Designer, and then making them making them real in Dynamic Query Analyzer and running it through the Aggregate Advisor workflow and showing how you can apply a combination of user-defined in-memory aggregates, advisor-recommended aggregates, as well as those priming reports as different approaches to improving performance by priming those caches and preloading those caches with aggregates. Okay, and so but today we're going to focus on something that's kind of overlooked sometimes, but I think it's important to go over is optimizing the cube model. So when you're in Cube Designer, you may see several entries under the Performance Issues tab. These are warnings. They're not errors. They're warnings intended to just alert you about some modeling issues that you may have room for improvement. The reason why we have this tab here is because the cube model and anything you define in the cube model is the basis for all the SQL queries that are generated from the engine, whether it's at cube startup, load time, or even data queries for loading those in-memory aggregates or any data queries during when running reports. So as a preferred practice and strong suggestion, you should really look at optimizing your cube model before looking into any of the additional kind of database tuning or creating aggregate tables and all that first. So you want to get a good basis. Let's make sure your cube model is optimized as well as it can be. Let's get hands-on, and this is basically the same or very similar cube that we've been working with, historic sales, but we have some built-in performance issues in it. So we have this cube right here. I'm going to right-click, go to validate. Validate goes through some errors, like real errors, and there are no error issues here. I'm looking at the bottom pane here, 0 issues, but there are 6 performance issues here. So I'll draw your attention here to this bottom pane area. There are 6 performance issues. Let's see. So the first 2 performance issues, I'm just going to read one of them aloud. The measure dimension of the cube historic sales perf issues contains a calculated measure, in the name of the calculated measure. Calculated measures should be restricted to expressions that use functions which cannot be pushed to the database. Determine whether the calculated measure could be modeled as a measure. And when we mean model as a measure, we mean as a regular base measure. Okay, so let's take a look at these first 2 performance issues, see if there's anything we can do about them. So this first one's about the product percent of total sales calculated measure. So let's take a look at that measure real quick. We'll go into the cube, double click on the measures. To open that up, we'll go to the calculated measures tab. You'll see product percent of total sales. I'll double click on that and take a look at it. And here it shows the expression. It's a tuple current member of product classification for the measure sale total over a tuple of all for sale total. As you can see here, there are a bunch of dimension functions used here with tuple, current member, and so forth. And so since there are dimension functions being used here, it cannot be rewritten as a direct expression, a relational expression against the database. So if there's anything you can do about it, it is what it is, and this is the functionality that we need to use. We can ignore that first performance warning for that particular measure. Again, they're just warnings. It's just to alert you, hey, you might want to take another look at this if you can do something about it. Sure. But in this case, it is what it is, so that's fine. Going back to the cube and the list of performance issues, the second measure dimension measure that it called out as a calculated measure is profit margin. So let's take a look at that one and see if there's anything we can do about that. So profit margin, open that up. Okay, so this one looks pretty simple. It's just profit over sale total. This one is basically just determining the ratio of the profit margin against the total sales. This is something that you might want to rewrite and push down to the database. Now, there are some advantages of keeping this expression as a calculated measure. One of them is, depending on whether or not you have summary tables or the basic nature of this expression, or how this measure might be used in other expressions later on, you might want to rewrite this as a base measure. One advantage of keeping this as a calculated expression is that you can leverage any summary tables that include those reference measures here. So if you have any summary tables that have profit in them or sale total in them, you would be able to kind of leverage those summary tables for those constituent measures. But you know what? But I don't have any summary tables with that, so let's remodel this calculated measure as a base measure so that it does push that database expression down to the database. Let's first go to calculated measures. Let's delete this measure here, and let's create a regular base measure. We'll go back to the Editor tab. We'll click on New. We'll rename it to what we had before, which is profit margin. Okay, and we'll double click on that. The expression editor, or we put a relational expression in here. So we can pretty much do the same expression we've had before. It's profit over sale total. There. So you can see the expression is exactly identical to what we had for the calculated measure expression, but the difference being here, in the engine, this expression will be an expression pushed down to the database. So one other thing to take a look at here is at the bottom for this base measure, the regular aggregate property. Right now it's set at sum, but we'll want to set it to calculated. And what's the difference between sum and calculated for an expression like this? Well, if we keep it as as regular aggregate of sum, what this would do is when creating the database expression, it would actually do a sum of the expression sum, profit, and sale total. So if that's what you want, all right, leave it at sum. But if you change it to regular aggregate of calculated, what the expression it'll aggregate over the query before determining the expression. So it'll be a sum of profit divided by the sum of sale total. And it turns out this is actually what we want. We want to sum up all the profits and then divide it by the sum of all the sale totals. So let's change that regular aggregate property to calculated here. Okay, let's validate that expression is okay. Yep, looks good. All right, so if we go back to the Performance Issues tab, now the performance issue is a little bit different. It says the measure, profit margin, is a regular aggregate of calculated, which is what we set, right? And it's just mentioning here that the queries at grains higher than the fact will perform slower than other aggregations. Create aggregate cubes to handle these queries to avoid requiring the routing of the query to the fact table. So it's just a reminder to you, that this will be pushed to the database, and if you, want to have better performance for a calculated measure, which we will treat as a non-additive measure, probably want to have some summary tables to cover that. And it's worth noting and remembering that summary tables can only really be leveraged for a measure, for a non-additive measure, that includes that measure as well as an exact match, meaning it would have to match all the specific levels in that slice in the query as well as the summary tables. So because summary tables for non-additive measures can't be used for high-level roll-ups, this is one of the trade-offs as a regular measure of type calculated versus a calculated measure, which uses dimensional expressions. Okay. So that's that for those two performance issues related to calculated measures. Let's take a look at the next one on the list. Here's the third one. The dimension product is a snowflake dimension. Queries using snowflake dimensions perform slower than queries using dimension tables because additional table joins are required in the generated SQL. Kind of speaks for itself. You know, with the additional table joins, it is a little bit more work for the database. So basically, this warning is telling you, hey, you have a snowflake dimension. You might want to take another look at that to see if that's what you intended to do, or if there's anything else we can do. Maybe on the database side, maybe talk to your DBA. Is there something we can do to maybe denormalize some of those tables or whatnot? But let's take a quick look to see if the product dimension is modeled as we want it to be. So let's double click on the product dimension, bring up the dimension editor. Let's take a look at the implementation tab. It is a snowflake schema by design, and you know, our DBA has no plans to denormalize any of these dimension tables. So the only thing we can really do here is to ensure that the join columns that we have here are correct, and basically just kind of move on and ignore that warning. But you know, it's just worth mentioning, as it is a preferred practice that less joins in the SQL is better for performance. But as we kind of went over here, there are several reasons for using a snowflake dimension. So we're going to ignore this performance warning for now. But I'll show you quickly how to take a look at the join. So in this tab, we can double click on excuse me, that line here for that join, and that'll open up the edit join dialog. Take a look at that. Looks good to me. All right, and we do the same for the other joins as well. Number one, yes, that looks good. Okay, and all right, that looks good too. So, all right, we have a snowflake dimension. That's fine. It is what it is. So, but we did take a look to verify whether or not those joins are okay. All right, so the next one on the list, actually the next 4, 5, and 6 are related to level keys. And so I'm just going to read one of them. The level key quarter in the level quarter in the dimension time has an attribute with a data type that is not integer. Integers should be used as keys in order to maximize performance. So, and the other ones also are talking about level keys as well. The next one about the level quarter in the dimension time uses a composite key for its level unique key. Composite keys can affect performance by unnecessarily including columns in the generated SQL. Ideally, you would want to have a unique key for each level if necessary by a surrogate key. You may need to trade off that in order to uniquely identify members, especially in slowly changing dimensions. Determine if all of the keys are necessary to uniquely identify the members. Why all this checking for level keys? Well, it's because level keys are a major part of the cube model, and getting them efficient and right as possible is crucial to kind of number one, the correctness of your cube in terms of the members in your dimension, but also the response time for the queries that are run from the cube. So as one of those performance issues mentioned, level keys are used to determine the uniqueness of the members on the level, and are pretty much used in every aggregation query that's pushed to the underlying data source. So it's really a preferred practice, the best practice, to make sure you have a kind of a single numeric surrogate key for your level keys. Otherwise, you'll get these performance warnings here. If you have level keys that are composite, meaning you have more than one level key, more than one attribute to define the level key, or if any of your level keys are not integer or long columns. Now, I get a question sometimes about, well, I do have a numeric, I have a float or a double or something like that. Is that okay? I'm like, well, yeah, it's a lot better than using a string. It's just that the different RDMSs have different implementation and optimization for queries with floating point precision, and so our checks in Cube Designer at this point in time really just check simply do you have an integer or do you have a long? If you don't, then I'll show a warning. But if you have a numeric and your underlying database does perform queries against floating points better than strings, great. You continue using that numeric. So basically, it's just kind of alerting you to the fact that the data type for these level keys does have an impact on performance as well. So that's that. But let's take a look at this first warning about the level keys for the quarter level. So let's take a look at our time dimension. Double click on time, and then we're going to expand. Actually, let's expand the levels folder here, and take a look at the level called quarter. Let's double click on that. Bring it up in the level editor. All right, it just looks like it has one attribute. Let's take a look at the level keys for this, and it's right here on the right-hand side. This button, level keys. Bring up the level key dialog, and in this case, you'll see that there are two attributes used for the level key, both quarter as well as year. In the database, the quarter column is basically just a value that says Q1, Q2, Q3, or Q4. So on its own, just Q1, Q2, Q3, or Q4 on its own doesn't uniquely identify all the members on this level, since you can have quarters across years and they basically have the same value. So, Q1 in 2013 and Q1 in 2014 both have the quarter name of Q1, so that's not unique enough. So that's why, there's the additional attribute here of year to kind of uniquely identify. The combination of these two attributes would uniquely identify each quarter for that level. But you know what? Let's take a look at the time source table to see if there's anything helpful or interesting that we can use instead of using those two attributes. All right, so let's take a look at time. What we can do is a view data on that database table for time. And by doing view data, it does a query to that in our database. It does a quick little sample, and we can see the columns and a little sampling of some of the data that's in that table. This can actually be really helpful while you're modeling your cubes to take a look, to view data and take a look at the structure of your database tables. It's nice that Cube Designer has this little feature in here, so you don't have to go back and forth between maybe this and another database client application. Okay, came back. Great. So you can see here we have the different columns for the time table, and actually we see that there is a quarter key column here in the time table that could be leveraged instead of using a combination of quarter and year. And it is a single numeric attribute. So, hey, plus, we can get two of those errors out, or two of those performance warnings out in one shot. So let's do that. Let's use this quarter key attribute or column instead of the combination of both these two for identifying the level key for the quarter level. So let's go back to the quarter level, open it up in the level editor. So in the source pane we have here that. Let's drag, open that up, quarter key. Let's drag that over here and add it as an attribute. Let's open up our level key editors, the dialog again. Let's remove quarter, let's remove year, and add quarter key as the level key. And that's all you need. That's all we need, right? Since it's just a single numeric attribute that is kind of uniquely identifying that level. And let's, we can still keep quarter as the number caption, because that is a readable, nice little number caption there. And that's it, really. So let's take a look at select time again and go performance issues. Great. So that performance warning about the quarter level is gone. Now we just have that remaining one about the month level. So that's good. One thing I want to do show you though is if we were to take a look at the SQL that would have been generated by the engine for that level, if you use composite keys, and let's say you were to have a report looking for total sales for the first quarter of 2012, On the left-hand side of this table, this is what the SQL would actually look like for that piece of information. It would include both the year and quarter columns in the select clause, in the where clause, as well as the group by clause. Now by changing it to just using that single numeric attribute, quarter key, it significantly simplifies the SQL with just a single numeric lookup here. In the select clause, in the where clause, it's a simple comparison to a numeric and a simple group by. So definitely optimizes the SQL by doing those two things. All right, let's go back to our where model, and let's take a look at that last performance issue where with the month key is using a calculated key. What does this mean? What are we talking about? Let's take a look at, we'll double click on the month level. And one thing to note, and I think I missed this earlier, is you can see that there is performance issue with the month level. You can see this little white badge, looks like a dial, a performance dial, so you'll know it kind of corresponds to performance issues, that there is something to take a look at here for the month level. It has that little badge. Okay, all right, let's take a look at the level key. What level keys are being used here? Month calculated key. All right, so let's take a look at month calculated key. It looks like it actually is an expression here. I'm going to select that. And the expression here is basically taking year times 100 and then adding that to the month number. So it looks like in this scenario, to avoid using a composite level key like we had in quarter, the modeler decided to use an expression to create that single numeric attribute. But unfortunately, this will actually result in not the best SQL in the world because that expression is pushed down to the database. So let's rewrite this and let's redo this as a single attribute column, and as luck will have it, there actually is a month key here as well. So let's fix that up. Let's go back to level month. We'll drag in the month key, open up that, we'll move that, add the month key as a level key. And we don't need this calculate month key attribute anymore, so let's get rid of it. And that's it. So we still want to keep the attribute of month as the member caption. Our new level key is just a single column lookup of month key instead of the expression. And you can see here, if we click on that and go to performance issues, there are no performance issues anymore, and you see that the little performance badge is gone on the month level. It's good. It should be now performance. I will mention though, not all attribute expressions are a bad thing. If you use an expression to create a member caption, for example, or just another attribute value for a level attribute, these will only have a one-time impact. It's only going to have an impact on the SQL during metadata load because we load the caption and the attribute values once. But attribute expressions for level keys, on the other hand, those are included in all data queries. So having an expression for level keys is not recommended. Okay, so level keys, expressions, no good. Expressions for captions or other attributes, okay. So let me just show you real quick the SQL again if we were to have kept it using an attribute and expression. So again, for that report for total sales for, let's say, the month of May in 2012, if we had kept it using the expression, this is what the SQL would look like. You'd see the expression of the SQL in the select clause, as well as the where clause and the group by clause. So 3 times, a little too much. And by changing it to just that single column, it significantly simplifies the SQL there. So a little peek inside about what actually happens when, what you do defining your model affects what happens in the SQL that comes from the engine. Okay, so think those are all the performance issues that I wanted to cover here today. Just the ones remaining are the ones that we couldn't do anything about, and it's okay to ignore. Just to note here, there are other performance issues that you might run across that we won't cover here, but I'll just call them out here. Joins between dimension tables and fact tables that aren't of type integer or long, those will be called out as performance issues. Again, the best performance types of joins are on data types of integer or long, and that's not to say that float isn't. It really depends on the underlying database implementation of that. So we're trying to follow best practices here, so we'll just identify ones that aren't of data type integer or long. Also, it'll call out any joins between columns for dimension tables for a snowflake schema that aren't integer or long. If the number of dimensions or the number of measures exceeds the best practice recommendations, it'll call that out as well. Or if, and I know last time we showed the dimension filters, if that option to exclude facts without corresponding dimension keys is enabled, there will be also a performance warning there too, because setting that property does add joins to the SQL. But, again, that might be what you want and what you need for your functionality and something that can be ignorable. So, again, these are performance warnings, something for you to take a look at that you might be able to improve in your model to improve the queries. Okay? So that's that for the optimizing the cube model, and the last part for optimizing a cube's performance. Okay, and then we're going to move on to the next lab module, which is enabling reporting and analytics on historical data, as well as planned trends in one place. So basically we're going to use a virtual cube scenario here, bringing multiple facts together. In last year's lab and in previous labs, we had talked about virtual cubes, and virtual cubes being a merge or a union of the metadata and the data of two underlying cubes. And those two underlying cubes can be two base cubes, as shown here in the color blue with the historic sales and target sales, or they can even bring together another virtual cube and a base cube, or even two virtual cubes together. But it's basically bringing together exactly two cubes into a virtual cube. What virtual cubes allow you to do is bring together kind of any shared dimensions between those cubes and allow you to build reports that use the information from both of those cubes in one place for that top virtual cube, the sales virtual cube. A lot of the merging that goes on when you first model your virtual cubes is based off of the dimension names. So any dimensions in those two constituent underlying cubes to your virtual cube, if they have the same name in both of the cubes, they'll be merged automatically to create virtual dimensions. The dimensions from one cube that don't have a corresponding dimension of the same name in the other cube are not automatically merged together, but then there are just added to the virtual cube itself. Now you can manually merge the source cube objects in the virtual cube that aren't automatically merged, and we'll go over that in the lab. But some things to consider as a modeler when you're working with these metadata objects is you want to make sure that the things that you're merging make sense to merge, or you might want to take a look at if it makes sense to even bring into the virtual cube itself. There might be some things that you want to just keep in the base cubes and not expose in the virtual cube itself. So just some things to consider when you are bringing together underlying cubes into a virtual cube. Okay, and so let's get hands-on, and we'll bring together that historic sales cube and the target sales cube, and we'll create something called the target to actual sales virtual cube. This one will share some of the same dimensions and some of the same measures, but not everything. So they're in kind of different contexts, right? So some of the measures are based on kind of planned data versus the actual data in the historic sales cube. And we'll also take a look at how to manually merge some of the dimensions that don't actually have the same exact names, but they are conceptually the same thing, and we'll create a virtual cube calculation that shows kind of the variance of the plan from the target, by subtracting the target from the actual values. All right, let's open up a model here that has another cube. So we've been working with the historic sales cube and should be pretty familiar with that so far, but let me just open it up just so you can see real quick. Historic sales, again, has the 5 dimensions: order method, product, promotions, retailer, time, and a set of measures here. In this model, we have another cube, target sales, with our planning data, and it has just 2 dimensions here: time to month, product type, and a smaller set of measures. Let's take a quick look at the time dimension here. You'll see that the time hierarchy and the time to month dimension only goes up to the month level. Okay. Whereas for historic sales, that goes down to the day level. This target cube only goes down to the month. And let's take a look at product type dimension. It only has one hierarchy, and that only goes down to the product type hierarchy. Whereas the product dimension in the historic sales cube has several hierarchies, with the product classification hierarchy going down to the product level. So this target sales cube is at a different level of granularity, a little higher up, and only has a subset of the dimensions there. Let's take a quick look at the target sales cube here. Open up in the cube editor, implementation tab. Show a little bit more detail here. Very, very simple star schema with the target sales fact table in the middle and time and product. Exact same tables, actually, the time and product classification tables that are used in the historic sales star schema. Okay. All right. I don't have this cube just yet in my system, so let me just publish that. And that'll publish the target sales cube to the content store, as well as assigning that cube to the dispatcher. And if you notice, I selected the option to start the dynamic cube, so it's starting the cube. And one of the reasons why I'm doing this is because we already have our historic sales cube up and running. I want to deploy and start this cube as well, so that when we go through the creation of a virtual cube, it does kind of take a look at what are the cubes out on the content store. We can choose from the ones that are either in the model here, in the model file, or that are available in the content store. So let's select model up here. Let's create a new virtual cube. You can either use the tool bar action here, or right-click new virtual cube. We'll do that. All right. So let's select both historic sales and target sales to be in our virtual queue. We'll click OK. And collapse these a little bit to make it a little easier to read and see. So we have a new virtual cube here. Let's rename it, and let's call it target to actual sales. Okay. Let me open that up real quick. Let's rename the measure dimension from historic sales to sales. This is because the measures folder in the virtual cube is generated with the same name as the measures folder from the first source cube that it found. And in this case, the first source cube that it found was historic sales, which is why it was called historic sales. But let's call it sales. That's what we want. Okay, so this new virtual cube generated a bunch of the same dimensions as the source cube, and it's basically, as I mentioned earlier, virtual cubes are a union of the metadata of the source cube. So any of the cubes included a dimension or a member and didn't exist in the other source cube, it'll still appear in the virtual cube. So you'll see time and time to month, both of them were here. They weren't automatically merged because they didn't have the same name, but they both included both of them anyway, as well as product and the product type. So let me double click on the virtual cube to bring up the virtual cube editor, you can see how each of the source cube dimensions kind of line up here. So yeah, so as I mentioned, it does have time and time to month, but they didn't line up because the names weren't exactly the same. But let's manually merge them together. So what we're going to do is we're going to remove this virtual dimension for time to month because it doesn't need to be on its own. We're going to actually correspond it to the time dimension. We're going to delete that. Okay, and then we're going to click on this button here under on the same row as time, but under the target sales column, to select the corresponding dimension here, time to month. Okay, so that's that. Let's do the same thing for product type. Let's remove product type as its own. It doesn't need to be its own virtual dimension, but we do want to correspond it to the product dimension here, and select product type. Okay. So yep. So now we've aligned, or manually merged and associated those two dimensions with each other. Okay. Let's take a look at the virtual hierarchies now. Let's double click on the time dimension and take a look at the hierarchies there. Looks like both time to month as well as time both have the same named hierarchy, time. So that's good. Let's just double click quickly on the virtual hierarchy for time to see the levels and how they're merged. And you can see for the historic sales time hierarchy, it does go down to the day level, and for the target sales hierarchy, it only goes down to month. That's okay. It's just a visual for you to see. Year, quarter, month, they all correspond to each other, but only historic sales goes down to the day level. And it's only going to be available from the historic sales cube. Okay, so let's go back to the product dimension, take a look at that one, take a look at its hierarchies, and you can see here it has 4 hierarchies, 3 from the historic sales cube and 1 from the target sales cube. Now, the reason why it added this again is because the name product type from the target sales cube did not exactly match any other hierarchy, so it added it on its own and it wasn't automatically merged. But you know what? Let's manually merge it, because in our understanding, in our world, we know that product classification and product type are actually the same thing. So let's merge that. So let's delete this extra virtual hierarchy, and let's click on this here to associate it with the product classification. And since we do have 2 different names, I'll want to rename this so that I know it's actually maybe something like product classification type. I'll double click on that virtual hierarchy here. Taking a look again that the historic sales product classification hierarchy just goes down to product type, goes down to product, and the target sales goes down to product type. So a little bit different there, but that's okay because everything else lines up to the product type level. So let's define some virtual cube calculations, calculated measures. So virtual cubes do offer the same ability to define calculated measures, just like regular cubes do, but it's worth noting that virtual cubes don't actually merge or bring in any calculated measures or members from your source cube, so you have to define them or redefine them in your virtual cube. Open that up, open the sales the measures folder up. Take a look at the measures here. This is okay because none of the measures have identical names, and some of the measures only exist in one cube or the other. So this is fine. We don't have any manual merging to do here. You have the choice to delete any measures that you might not want to expose in your virtual cube. So for example, if for the unit cost, unit price, or unit sales, any of these measures you might, if you don't want to expose in the virtual cube, you can select it here and delete. It'll remain in the base cube itself, but it just won't be in or available in the virtual cube. Let's create a calculated measure. Click New. And let's rename this. I'm going to select it and hit F2 to rename it. And I'm just going to call this Sales Total from Target. We want to know how far we were from our planned target. In the pane, we're going to click on expression to bring up the multi-dimensional expression editor. Take a look, open up the measures here. We're going to do sale total minus sales target. Let's verify that syntax real quick. Okay. And let's add another calculated measure. We're going to call this sales percent of plan. We're going to know the percentage how far we were off our plans. We're going to take that calculation we had from before, and over here, over our sales target from the sales target base cube. And so this is the percentage. I'm just going to set a data format for that as well. The percent. And I want the symbol to be this guy. Okay. All right. So that's that. Let's publish this cube, this virtual cube. Hopefully there's some errors. Let's take a look at that. Okay. Maybe it didn't say. Perhaps it didn't say what I said. That's weird. All right, let's redefine it. Sales total minus sales target. Okay, validate. Okay. Click away. All right. Now it's fine. All right. Let's publish again. So let's try to publish again. So what it's doing now is it's publishing just the virtual cube, target this actual sales virtual cube, and starting that virtual cube up. So when starting virtual cubes up, it first takes a look to see if its underlying base cubes are started and running. It's so great, and then we'll load its virtual members and stuff. So now that cube is started. Let's run a report to take a look at what that does. And just quickly, I'll show you in Cognos Administration again. Taking a look at under the Status tab, Dynamic Cubes tab. Again, this is new in 10.2.2. They renamed the data stores to Dynamic Cubes as the one-stop shop for all your Dynamic Cubes needs, or most of your needs, I should say. All right, so under the data stores, you can see all the different cubes here. We'll have target sales and target actual sales virtual cube. You can tell it's a virtual cube by its icons a little bit different, and they're all available. Great. Let's go to public folders, Dynamic Cubes Lab folder, and let's go into the target actual sales package where I have one of these reports, which I'll run. So when a query or report is run against a virtual cube, it splits up that query and runs it against each of its constituent underlying cubes. Part of that information that it gets from one cube, it then merges together with its second cube to provide you those values. If you remember from last year's lab, we had a virtual cube that was historic and recent, where the historic sales cube brought in the data from all the way up until the current month, and the recent cube had the data from the current month. So when you did a query for the whole year, you'd actually get the entire picture because it merged the values from its constituent cubes. In that case, it was very easy to see because it was split on months. But if they had some overlap, you would actually see the values are merged together. So, all right, so this report came back. It's just a simple report with the different measures, sale total being a measure that's only found in historic sales, sales target being a measure only found in target sales, and then these other two are those two virtual cube calculated measures that we just created. And you can see these show the relative values, pulling together the values from both cubes into one place here. So let me just drill down into the year 2014 real quick and show you the quarter level. You can see that all these values are relevant still to the quarter level. We drill into Q1. Again, all these measures are still valid at the month level because both cubes do go down to the month level. But let me drill into January to go down to the day level. As you remember, the day level only exists in the historic sales cube, so that's why the sale total, which is the measure only found in historic sales, has values, whereas the value for sales target, because the target sales cube does not have a corresponding lowest level of day here, it shows no value there. And correspondingly in the calculations, when you have no value, we can't give you a corresponding calculation based off of that. So that's what you should expect to see when you're trying to merge virtual cubes and you have dimensions that aren't all conformed. And so I think that's all I wanted to show here. So you were able to see how you can bring in data from your actual sales, your historic sales cube, as well as maybe from your trends into one place you can report all on both of those sets of information in one cube, in one virtual cube.